In this video, I'm going to be talking about quite a few different things in relation to a new web application that basically allows me to query and talk to my own PDF files from my local machine. And so I've created a flowchart here to show you the technology that's involved and the basic steps that I'm going to be talking about. First, I'll show the working application that I have hosted on render.com, so you can see it can actually be deployed to the public side on the internet. And also I have it running locally on my machine here, my Windows 10 development machine, and that's the code that you see on the left side of my screen. And then we'll take a brief look at the Pinecone database cloud, so you can see basically what that looks like when it's new, and then I will bring a screen over here to show how it is up and running, and also I will walk through the basic steps of creating a web service on the render.com so you can see how it gets deployed. So that's a lot to talk about, and so here let's take a look at my flow chart. Basically the different layers of the application and the technology that's being used. First of all, there is the Pinecone database vector base. There's Langchain, which is a really awesome modern framework to help develop applications like this. And then there's TypeScript, which is used in the code. OpenAI, which I'm using my OpenAI account. The Turbo model, like Turbo 3.5, since I don't yet have access to 4.0 for the API. And also the code here on the left side of the screen is using React and Next.js. So that's the technology. And then if we look at the overall layers that are being used here in the code, basically we have the front end, which is where you ask it questions. And then there's the Pinecone vector database. That's where the PDF files that I ingested, they're stored up in the cloud in the Pinecone vector database. And then when you're asking it questions, you're actually asking it questions about your own PDF data. And I use the Tesla 10K annual reports, and I think it's something like 1,000 pages, more or less. I also used this whole program and setup to ingest other kinds of information, and I was querying and asking questions against those also. And I'm in process of developing more functionality for this program, and I'll show some of it in one of the screens, the new screens that I've been working on. And so then, yes, behind the scenes it's talking to the web API on OpenAI and interfacing with that system and doing different things. And then the Langchain framework, things like the text splitter, embeddings, vector stores, document loaders. There's a lot of different things that is doing in this code. And then finally, render.com, hosting this application, like I'll show in just a moment, out on a public URL. So that's basically the steps that I'm going to go through at a high level. I may make a more detailed video about some more specifics, but I think this video will cover a lot. So I will come back and reference this flowchart from time to time as I go through the steps. And this is actually running on the render.com. And so you can see the URL there and what the interface looks like. And basically it's saying, hey, what would you like to learn? And also it's mentioning here, chat with your own PDF documents. As I mentioned, I used a command line script to ingest all my PDF files and get them set up in order to work with OpenAI, kind of like chatgpt. And so in this section is where you type your question to search the contents of our PDF documents. And also I mentioned here, click the link at the top of the screen to see sample prompts to get you started. And I will show that page here in a minute. And then I have a note here that just says that I ingested 3 PDF files, like 1,000 pages of information from the Tesla annual reports, which I just downloaded from their website. I believe that's called the Form 10K. And I couldn't find 2021 annual report in a PDF file, so I used 2022, 2020, and 2019. So that's basically when I'm asking it questions, that's the information it will be querying against. And I just had one other note here. Tech stack used in the app includes Langchain, Pinecone, TypeScript, OpenAI, React, Next.js. Langchain is a framework that makes it easier to build scalable AI and LLM apps and chatbots. Pinecone is a vector store for storing embeddings and your PDF in text to later retrieve similar docs. So let's go to the second page here, which is sample prompts. And this is a page that I've been working on, but as I was querying my PDF files, I decided to save these prompts to make it easy as an example to have it query and run these prompts anytime I wanted. And this list, of course, it's not database driven now, but it could be. I mean, there's a lot of things you could do with this. And I intentionally misspelled some words. And another thing to take note of here, it says you selected Tesla reports. I will be showing that in the code and in the Pinecone database, so you can see how they tie together or are linked together. And another thing that I'm working on here is selecting the data set that you want to work with. So what this really means is once I add in the ability to link to different PDF files and ingest different PDF files, you would be able to select this from the drop down. Like if you had legal cases or legal documents you wanted to query. I mean, this can be any information that you would ingest into this overall system. Or let's say we're going to have information about SharePoint documents and you wanted to ask questions or query against that. So you would just change that, and behind the scenes, it would select or point at the correct data store in the vector database and in the code. So that's basically the idea there. I'm still in the middle of working on that functionality, but let's go ahead and click on these prompts now and see. And so once I click on it, it will go over to the main page and it'll start running it. And so you can see here it says waiting for the response, and it's fed in the prompt from the other page. And so here it's pulling out information from my PDF files, and you can check the source. It lists the source here, and it says, okay, here's where it originally got it from when I imported it. And then if you want to check a second source, you can see more information that it pulled up and where it got it from. So that's really nice to be able to see the source of where it found it inside your PDF files. So let's go back and say we want to ask it about Tesla capital expenditures projected for 2023. And let's see what it finds. So that was pretty quick. Here it's telling us the Tesla capital expenditures projected for 2023 are between 6 and 8 billion. And so if we looked at the source, where did it find that? Well, it's pointing out here. It found it in this 2022 1231 PDF file. And it also found information here in this PDF file. Well, and let's do one more. Let's say we want to know what Tesla vehicles have an active production status. And so we can see it's telling us the Tesla vehicles that have an active production status are Model S, X, 3, Y, and Cybertruck, and some additional information. So here we can see where it found that information in the PDF files. So that's just basically at a high level how I've used some GitHub code that I found and been changing it into something more that suits my needs and allows me to feed in my own prompts and feed in my own PDF files. And I will be making it more dynamic, and we'll show that in future videos once I accomplish some of these other things, like being able to ingest my own PDF files, or I should say additional PDF files, and then be able to have it target those by just using a drop down. So if it was within your company, like maybe you had HR documents you wanted to query, or financial documents, or documentation, whatever it might be, by selecting the right data set here, it would target this code to reference or use that information. So what I just showed basically entails all of these different pieces. As I was querying it and using it, it was using all of these different pieces of technology. And then I have it running here on localhost, so we can run it from there. Let's see here. How about what is the location of their primary manufacturing facilities? And so it says they're headquartered in Palo Alto, California, and some additional information. So basically it's up and running from this code here, locally and in the cloud. So I've switched back to my flowchart here. Let's take a look at the Pinecone vector database and what that looks like at the beginning when you get signed up for an account. So basically, this is what it looks like, and you would have to say create index, and then from there you would give it a name and some basic parameters that you have to feed in. And I'll show a working example in just a few minutes, but I wanted you to see the kind of like the raw format of it here. And so there's like documentation you can access, information about your profile or organization. There's public collections that you can possibly use, collaborators if you want other collaborators. I'm on the free plan, and your API keys. So you have to set those up in order to use in the code, which I'll show that. And like I don't have any collections because this is a brand new account for the purposes of this video. So now I'll click on create index, and you can see what that screen looks like. And so you would put in a new name, and that needs to match up where you see it in your code. So let's click on here, and I'll have these two screens open. Basically, dimensions, you have to follow the recommended, which is 1536, and I use this metric here. And pod type, I selected S1, and I'm in the starter plan, so you can see an important note here that indexes, that's what this is going to create in the starter plan, will be terminated after 7 days of inactivity. It's really important to pay attention to that, because you will lose your data if you're using this to experiment with. So pay attention to that. And you can see also that I'm on the starter plan, so there's no monthly cost. But I won't be setting this up in this account because I already have it set up. So I wanted you to see how that gets set up and what it looks like in Pinecone. Well, I changed my mind. Let's go ahead and create so we'll call it Langchain JS index dimensions 1536. That's what the recommendation was in the original GitHub code. And so these other options are fine. And then I'll click create index. So it says it's initializing, so I'm going to pause the video and we'll come back when it's done and take a quick look at this screen. Alright, so it finished and it says it's ready. And so we can see there's no vectors in here now. That's basically what happens when you ingest or import your PDF files. That number will change. And so the other thing that's important here is the environment and the Pinecone index name. So I've put them over here on the left side of the screen so you can see where to plug them in if you're going to follow along and do this and you haven't done it before. So your environment goes right here, and your Pinecone index, which you basically get one for free, that's this here. I called it Langchain JS index, which goes right there. And then I'm not going to show an API key, but you will need to generate an API key here in this interface, which you just click on that, API keys. And once you do that, you just fill it in here in the Pinecone API key. And then the same goes for your Open API key. If you don't have one, you'll have to go to the openai.com website and fill out information to get an account created. And since I don't have access to the version 4 of the chatgpt API, I just use the Turbo 3.5 model, which I'll show that in the code also. So basically, once you import your data through this code here on the left side of the screen, it will show up as however many vectors, like 1,000 vectors or whatever it is. So a couple other things to point out here, like if you want to use a curl command to talk to it from a command line, they do have that listed in this area of the Pinecone site. And also there's a metric screen, which is kind of nice. If you want to just click on these, it will show information 10 minutes, an hour, 6 days a day, or 1 week. But since this isn't active, you're not going to see anything. You can also filter it on request type, so it's pretty nice. They have some basic built-in metrics here. And there's other things like doing upsearch queries, updates, fetches, deletes. So there's an interface here, which I'm not going to be using any of that in this video, but I just wanted to point it out. So I've gone back to the diagram here, and so there we looked at the Pinecone vector database and basically how it's set up and how to use it. That is where the PDF data goes after you run the ingest command, which I will show that here in a moment. And a few other things to point out in the code. This is in a pinecone.ts file. You can see those parameters that are referred to in your .env file. They're used throughout the program, but here we can see how it's grabbing the index name and the namespace. Now in my live system, I called it Tesla reports. And so in my code, it has that Tesla reports, and in my vector database, there is a set of information there that is called Tesla reports. It's listed here in the index information. So I pulled up my control panel so you can see a little bit better from the program that I was demonstrating. this is the Tesla reports. That's the namespace. I was using the wrong name there. Yeah, it's called namespace. And so that's where you can see here on line 11 that it's called namespace. And that's how it shows up after you ingest it into your Pinecone database or vector base. And you can see some metrics since I was using it. You can see how it was just being used when we were using it in the video. So anyway, just wanted to show that real quick so you can see how it's actually working from the front end. And then next, I'm just showing the pinecone-client.ts so you can see how it's starting up the Pinecone or initializing the Pinecone and using those environment variables that are in the .env file. So that's why it's important to have them set up correctly, and then the code will just work. So let's go back to the flowchart and see where we're at here. So we looked at the endpoint of where the data goes, but how does it get there? So this Pinecone vector database, it stores your or my PDF data in this case. So let's go ahead and see the code that ingests that. And there's a couple things here to show. The package.json on line 18. If you run npm run ingest like I have here, it runs this script and then it runs a file called ingest-data.ts. So that's how that gets run. And another thing is you can see the dependencies here, such as the Pinecone that had to get installed, Langchain, which version is currently running, PDF parsing, of course React things, tailwind, and then some other dev dependencies. So let's take a quick look at the document ingestion service or code. So there is a variable here or constant called file path, and I named it reports. And so if we look over here in the code, we can see my folder called reports. And those are the three files I mentioned earlier in the videos. Those are the PDF files that got ingested and stored over in the vector database. And so that's how it knows where to find them. And then you can see here it's using directory loader, a custom PDF loader method. And basically it's saying to grab all the PDF files, and then it's going to split them into chunks or split the text into chunks. And the chunk size is set to the 1000 and chunk overlap 200. And also when you see it running, you can see it outputting information in my console log, a lot of information. So that's basically why you see it. And then it's going to tell you, hey, okay, I'm creating a vector store, create and store the embeddings that it just created from this code up here. And it's going to point at the Pinecone database. And that's why you have to have those variables set up so that it uses your correct index name. And so now it uses the Pinecone store from documents and basically goes ahead and inserts them or ingests them into the Pinecone namespace. And that's why I showed that in the file here and in the Pinecone.ts file where it's called Tesla reports in my working example for this YouTube video. So basically that's what's going on. There's a lot of different code that's actually being used here. I'm not going to go into more detail about it, but that's a high level of how it gets imported. And so if we look at my chart again, now we've seen where it stores it, and we've seen how to ingest it and how it gets ingested and converted and then stored into the cloud so that the web program, web interface can access it, that we've looked at here. So now this program is pointed at the Pinecone database and the OpenAI web API, and it's able to combine that information together and output it here on the screen like we saw. So we can go ahead and maybe pick another one. Can you tell me what are Tesla superchargers? So it's generating the answer there, and it explains what Tesla superchargers are, and then it tells me where it found it in two sources. So this is, I mean, really powerful stuff that you can probably imagine using technology like this to have it ingest and use any of your own documentation or PDF files or text information. I mean, there's so many different options in these tools that I showed here. You have to just look at the documentation and other YouTube videos and so forth. It's pretty new technology, but I think it just opens the doorway to some really, really awesome and powerful searching and learning capabilities from your own information, and that's stored in basically databases that you manage and can secure the way that you need to. So here I've switched to another file called MakeChain. It's in the utility folder right here, MakeChain. And because I don't have access to the latest API, I had to go ahead and put in my model GPT 3.5 Turbo. In the original code, it was version 4. So that's just something to mention in this file here for getting things set up for your own environment. And at the top of these files, you can see like importing OpenAI embeddings from Langchain, importing Pinecone store from Langchain vector stores, importing MakeChain, importing Pinecone, and here in the MakeChain, it's importing prompt template, callback manager, Pinecone store, LLM chain, chat vector DB QA chain, and load QA chain, as well as OpenAI chat. So like, of course, you can move your mouse over these and get more information. And this is basically what I did on the sample prompts page, if you were wondering. I just wanted to keep it really simple for right now, but basically it's calling the home page and feeding in a prompt. And these are all the prompts that you saw on the main page. Just a really quick and easy way to feed in your own prompts. I'm in process of making this part database driven, but for now this works fine. And so it takes that information back on the index page and feeds it into the code and runs it to generate the question and answer scenario. So back on the flowchart, I just covered really briefly the Langchain framework and some of the things that it's doing. And it's incredibly powerful, and you definitely want to check out their documentation to learn more about it. I will be in the upcoming future. So to start wrapping up the video, we'll take a look at render.com and how I got this GitHub code set up and running on render.com. And because the database is hosted in Pinecone, you don't need to pay anything on render.com to have it deploy your front end, which is really nice. Now I do have an account on there that I probably have talked about in my other videos that I use to host some different things, and it is an inexpensive paid way to do that. It's one of many cloud providers that I've worked with in the past. So let's go ahead and take a quick look at the render.com piece. If you haven't used it before, you may want to check it out. It's pretty cool, pretty easy to use. I really like it a lot. And it can do some things for free. And if you do need to pay for it, it's pretty affordable. I'll just scroll down briefly and show a few of the features they mention here. Web servers, static sites, Docker containers, cron jobs. You can deploy things in seconds, update automatically. All your services in one place, run anything. Web services, that's what we'll be setting up to run this application. Static sites, background workers, cron jobs, Redis, Postgres, private services, Docker files. So you can see people talking about it on Twitter and what some other people say about the product. And they have good documentation. So anyway, if you haven't used render.com as a cloud provider, you may want to take a look at it. So I've gone into the Render account and I clicked on New, and then I clicked on Web Service, and basically that's how I got to this screen. You are deploying a web service. I called it Scott's Bot PDF files. That's in my GitHub account, and so I gave it a unique name here. The region where your web service runs, you can pick different options. We can pick, say, Ohio, more central United States. What branch do you want to deploy? The runtime, I just leave it set to default, which is Node. And root directory, since the GitHub code is hosted from the root directory, basically it knows how to go and get it. And these are the two suggested commands for the build command and the start command. I've used these to deploy this application on the other site that we were looking at, and it does work. And then your instance type, I'm going to go ahead and select free. As you can see, the pricing here for starter, you get more CPU power, same amount of RAM, $7 a month. Their standard is 2 gigabytes of RAM, 1 CPU. And here's a note here: unlike paid services, free services scale down when they're inactive, and they do have slower build times. And I won't go into the advanced now. I had this screen open for a little while, so I don't know if it's going to time out, but let's go ahead and see if it creates it for us. All right, I'll just let it run here. And see what happens. So I had some issues with the render. I went back and tweaked a couple things, which I will show. And right now it's building it. You can see here it's generating pages and optimizations and things like that. So let's let it finish and I'll come back here in a moment. And you can see up here it shows that it's in progress. It animates that while it's building. So there it says the build was successful and it's deploying it. So we'll give it another few seconds here. Again, we have to remember this is a free account or a free web service, so it does take longer than if you're on a paid account. And you can see that it says node detected node version 20.0.0, which was just released recently and in the last few days. But you can specify other versions, which is what I was thinking about doing. My other similar application here on Render is using an older version node, whatever the previous one was exactly, 18 point something I think, or maybe it was 19. I'll have to go check. So here's a page on the render.com talking about the node versions. They have a couple different ways that you can specify different node versions if you need to. And that's render.com/docs/node-version. That's the URL. I'll include it in the video description. So here I'm running it now. If we go back to this page, again, it says it's done, it's live right there. It says that in green letters. And so they have a link right here you can click on and it opens up a new window. So I can go ahead and close this and we'll pop it open here. Just click on this in the render page. And then that's the same application that we looked at that was deployed in my other render account. So that's basically what you have to do. And I do need to show the settings here that I changed. So I used these settings instead. I'll zoom in a little bit here. So npm install and npm run build. I was using a slightly different version in the other account. It may have something to do with node version 20 and those other commands. I'm not sure. I'm not going to spend time going into that right now because it does work. And I usually don't have issues building things on render. So anyway, that's basically a good overview of how to set things up inside of render. And one other thing I need to mention is the environment variables. As we saw in the VS Code window here, these four on lines 2 through 5, they have to be set up here in your environment variables inside of render. If you don't set those up, it won't work because it won't know how to access your Pinecone environment or your Open API, web API with your key. So you need to have those four created, and you just simply come to this environment screen and say add environment variable, and you put in the key name and the value, and then it saves it. So it's really easy to use from that standpoint. And once you have the web service created, like it says here, web service, and you put in those settings like I showed and put in your environment variables, after that you can have your code up and running as I'm showing here. So there's two other things I want to mention. I found this code in a YouTube video here in this URL in GitHub, and I took that code, made a copy of it, and made the changes. Some of the changes that I showed in this video. And also, I'm going to maximize my Visual Studio Code here and show this diagram that is included in that repo I just showed. This basically goes into more details about what was going on behind the scenes, such as down here in the bottom left, how it was taking the PDF information, converting it into text, taking the text, splitting it into chunks. Now you have these chunks, and it's going to create embeddings, and then it's going to store your embeddings into the vector store, the database like I showed. And that's where I was saying I'm working on making it possible to ingest multiple different sets of PDF documents stored in their own namespace. And then from the front end, you choose a drop down and say, hey, I want to query about these documents or those documents or this namespace or that namespace. And then in the top part of this diagram, you can see basically the front end, how it's taking your question and chat history and asking your question and using the language model. In my case, it was using GPT 3.5 originally. In that GitHub repo, it's using version 4, and you can see how it's combining this information together to build your answer here on the right. And you can see the diagram, the name of the person who created it is right there. So I wanted to point out that GitHub repo and this diagram. Other than that, I think that wraps up this video. I may make a more detailed video about some aspects of this in the future, but I hope this video helps you. I know it really helped me going through this process, and it's very exciting actually to be able to take your own information and be able to query it in this way, as I explained in the video. I think it's really powerful, and it's the future, or a big part of the future direction of one aspect of using this AI technology. So with all that said, I appreciate you watching the video and taking the time, and I will talk to you in another video. Thanks for watching. If you like this channel, please like and subscribe and hit the bell icon to be notified when I post new content.